This video is on reflection of waves, and this is for triple students only. So if we think about any wave and any material, they can either be transmitted, absorbed, or they can be partially transmitted. So for example, if you think about a light wave and a window, the wave is transmitted, it goes through. But if you think about a light wave and a brick, the light wave does not transmit, it is absorbed entirely. And you can have materials that are translucent, and that allows some of the light to transmit. For example, paper, if we shine light on paper, some of it will be absorbed and some will be transmitted, and I've represented the transmission by a dashed line. But some waves, most waves, can be reflected. If they're not absorbed, or if they're not transmitted entirely, they can be reflected. So if you think about a mirror, you can draw a mirror with some dashed lines to represent it's a mirror. If the wave hits it at an angle, drawing an arrow to represent the direction, it can be reflected. But we need to know what angles they can be reflected at, so we need to draw something called a normal. And normal is at 90 degrees to the object being reflected at. So here I've drawn a 90 degrees angle. So that is called a normal. To measure the angles we're interested in, the light ray coming in is called the incident ray. So this angle here is the angle of incidence, so label it I. This angle here, the angle of reflected ray, I'm going to label R, and that's the angle of reflection. And the angle of incidence equals angle of reflection. So for example, if this comes in at 45 degrees, the reflection goes off at 45 degrees. If the angle of incidence comes in at 60 degrees, the angle of reflection is 60 degrees. It stays constant.